Newton's law of gravitation says that the magnitude F of the force exerted by a body of mass m on a body of mass m is F, which is equal to G lowercase m capital M over r squared, where G is the gravitational constant and r is the distance between the bodies. In part A, we want to find the derivative of F with respect to r and explain its meaning. And what does the minus sign indicate? Okay, so first let's write out the function. So we have F, which is equal to G lowercase m capital M over r squared, where F again is going to represent the force and r is the distance between bodies. Okay, so what we want to be able to do is we want to be able to find the derivative of this function. Okay, so the derivative and before we do that, we can then rewrite this as F, which is equal to G lowercase m capital M, and this is r to the negative 2. So if we want to find the derivative of F with respect to r, then we're going to get negative 2 times G times lowercase m times capital M r to the negative 3. So if we want to write this derivative, we would have negative 2 times G lowercase m capital M over r cubed. So therefore there is the derivative of our function. And let's explain what this means. Well, this means that this is the rate of change of the force with respect to the distance between the bodies. The minus sign indicates that as the distance r between the bodies increases, the magnitude of the force exerted by the body of mass m on the body of mass m is decreasing. Now, in part B, it's saying that suppose it is known that the Earth attracts an object with a force that decreases at the rate of 2 newtons per kilometers when r is equal to 20,000 kilometers. How fast does this force change when r is equal to 10,000 kilometers? So let's go ahead and write down what's given. So what is given in this problem? Well, we know that it's at a rate of 2 newtons per kilometers and it's decreasing. So that means that the rate, which is df over dr, is equal to negative 2. And we also know that r is equal to 20,000 kilometers. So what we're going to do is we're now going to use our derivative formula, which was at the end here of part A. So we have df over dr, which is equal to negative 2 times G lowercase m times uppercase M over r cubed. So we're going to substitute df over dr to be negative 2. So we have negative 2, and that's equal to negative 2 times gm capital M over 20,000 cubed. Okay, so we're going to multiply both sides by 20,000 cubed. So that means we have negative 2 times 20,000 cubed, which is equal to negative 2 times gm capital M. And then if we divide both sides by -2, and therefore we have 20,000 cubed is equal to G lowercase m capital M. So now we know what GM capital M is equal to. It's equal to 20,000 cubed. So now what we want to do is we want to figure out, okay, what happens or how fast does this force change when R is equal to 10,000 kilometers. So we know that GM lowercase m is equal to 20,000 cubed. And so now we're going to be able to substitute that into our formula, which is our derivative formula. So df over dr, which is equal to -2 times gm lowercase m capital M over r cubed. So that's -2 times 20,000 cubed over r, which is 10,000 cubed. And so that gives us -16. But we want to know how fast this force is changing. So that means that we're not concerned about the negative here. What it's saying here is that it is changing at 16 newtons per kilometer. So that is how fast the force is changing.